Assuming we have a circle with the radius r is equals to 1. And let's assume two other points, one on the boundary of the circle and another inside of the circle, and by connecting them we are making a right angle triangle. Now drawing the horizontal and vertical components of these lines. I am using a software AutoCAD and finding the angle that is 37 degree and 26 degree. But for my purpose I am converting it into A and B, and I am eliminating the triangle associated with the angle A, and also I am eliminating the triangle associated with the angle B. Note that these both are the right angle triangles, which means the one of the angle in the triangle must be 90 degree, and the triangle associated with the B, the hypotenuse of this triangle is the radius of the circle, so it is 1 unit. Now we know that the hypotenuse of this triangle is 1 unit. For the base and perpendicular, we have the cos identity and sine identity. Remember that in a right angle triangle, if the angle A is given to you, the base would be hypotenuse times cos A, and the perpendicular would be hypotenuse times sine A. And in our case, the hypotenuse is 1, so anything which is multiplied by 1 would become itself. So the base will be cos B and the perpendicular will be sine B. We have find out the two sides of the triangle and inserting it into the triangle as well, and eliminating the another triangle, because we know that the hypotenuse of this triangle is cos B with the angle of A. Now here cos B act as hypotenuse, so the perpendicular would be hypotenuse times sine A, and in our case hypotenuse is cos B, so the perpendicular will become cos B times sine A. Same for the base, because base is equals to hypotenuse times cos A, and in this case hypotenuse is cos B, so the base would be cos B times cos A. We also find out the sides of the triangle associated with the angle A. And now making another triangle. Let's fast forward our video. Here we have the hypotenuse, which is equals to the sine B. We know the hypotenuse, but we don't know the angle. So for the angle, I have the software, so I know that it is equals to the angle which is A. Here in our case it is 37 degree. And eliminating this triangle too with the hypotenuse equals to sine B, and the angle is 37 degree. And we know that the 37 degree, in our case it is A. So converting it into A, because we want to derive sine double angle identity, and we know that in derivation we talk about generalized condition, not a numeric value, just like as 37. So converting it into A. Here sine B act as a hypotenuse, so multiplying hypotenuse with the sine A and the cos A, so we get the base and perpendicular. Don't be confused in the angle A and B. Remember, hypotenuse times sine, and the angle would be the angle which is given in the triangle will become perpendicular, and with the hypotenuse multiplied with the cos and the angle on the triangle will become the base. Now we also know the sides of this triangle as well. Now we have another triangle in which the both A and B angles are participating. Note that the angle in between this triangle will be the sum of both angles, which is A plus B, because it is the combination of these two triangles. As we know, the length of these two lines is sine b cos a and cos b sine a, and copying it to upside. Removing a and b individually and adding both of them. Here you can see that my software is showing it is 63 degree, which is 37 plus 26 that we have done earlier, and I am converting it into a plus b. And the length of its hypotenuse is equal to the radius of the circle, which is 1 unit. So it is so simple triangle, and the perpendicular of this triangle will become hypotenuse times sine a plus b, and in this case hypotenuse is 1. So 1 times sine a plus b will become sine a plus b. Surprisingly, the length of sine b cos a plus cos b sine a is equals to the length of sine a plus b. So here we are proving the sine a plus b is equals to sine b cos a plus cos b sine a. Here we have proved the sine double angle identity. For confirmation from the software, you can stay with me.